Hello all, we are here for the lesson number 22 of this VariCAD training course. This lesson is called Libraries of Mechanical Parts, and with this lesson we are starting a new section, the section 4, that is dedicated to libraries and mechanical calculations. This is a very short section because we are going to have only 2 lessons. This is the first one. The following one is already the last one of this section, but is a new chapter in this course. About the topics we need to see in this lesson. Basically, we want to see in either 2D and on the 3D side the insertion of mechanical components that VariCAD has already by default inside. So here in this 2D environment we can come to this parts menu and we have these 4 commands on top. Parts, and when we go to parts we are presented with the type of parts we can insert, DIN and others. And we have the same on the 3D side, menu parts, and we have again ANSI, DIN, other parts, and the type of parts inside. So basically, with this capability of the software, we can insert several types of parts like screws, nuts, washer, pins, rings, rolled profiles, bearings, spline shafts, and some more. Okay. Also important to know, and I think when I show you in this menu the commands we have, it's possible to see the standards that the software has. So we have the American standard, the ANSI, we have the German standard, the DIN, and besides we have also other European standards, and we have ISO standards also. Okay, so basically we can follow a lot of things on the most common standards used worldwide. So we can insert several types of parts. I will not do them all, as you might understand. Let us do some examples to see the options instead. So for example, a screw. This is very easy to use in the type of the screws. We have all these types and a couple more in other on the following page, but let us see this first one. I think it's enough. So we have all these kinds of screws, all these families. We can choose one clicking on the icon, so metric 1. Then we must choose from this first list a dimension. I can select the M10, and when we select the dimension, according to each dimension there is a length possible to choose, because different dimensions have different available lengths according to the standard. So M10 I will choose, for example, 16mm length. And here in this board I have all the values that are that register what this part, in the case this screw, has. Okay, this is not editable. This is something that is inside the database of the program. Now I can choose how to draw this component. In the case of the screw, I can have a side view, head side view, or axial view. So let us introduce a side view. And now I can insert it by insertion point that is something introduced by default on the software. I can insert it somewhere I want. If I go again there and I choose again the screws, sorry, it was not the metric. Let us try to choose the same, not this one also. It was the other part, screw, sorry. Metric 1, I will choose the same M10, 60, and now head side view to see the difference. Okay, just the head. And last, screws, metric 1 again, 10, 60, and now the axial view insert. Okay, and that's it. So I can have different possibilities to insert the parts on the 2D side. For example, other types of parts, like the bearings, I have similar options. I can choose by families the type of bearing I want. For example, cylindrical roller bearings, and in this case we are using the catalog from SKF. I can choose a double row. I have all these references from their catalog with these dimensions, and now complete section to shaft, a section, and etching, showing the different parts. So complete section, insert, this is a big one, and here it is. Okay, so I think it's very, very good. This is the same basically for all the type of parts we have here, and we can choose a very similar thing on the 3D, with a big difference that on the 3D I have a solid. So let us try to choose the same screw just as an exercise. And screws, again, metric 1, we can choose the same, the 60 millimeter. Now I don't have any options because in 3D there is no ambiguity, it's the part itself and that's it. So insert, and we will choose where to insert it. Now I don't have anything in my environment, so it's just to insert a component. We will see on the following lessons when we are on the topics about the 3D, how to insert and how to manipulate all these things. Now it's only important to see the component being inserted. So do the OK, and the component is inside the program. Okay. There is another very interesting issue when we try to insert this, because now I've inserted a screw, a metric 1 M10, but I can do something a little different. I can insert a new one, or for example I can do the replace selected objects, and I can choose this guy here and do the OK, and it is inserted as a replacement. So for sure in this case I have only one component. Maybe you cannot see immediately the advantage of this, but when you have an assembly already with a lot of parts, it is a very cool feature to use. On the 3D we have basically the same components, okay, all these type of things. The same for the SKF also, because we've seen them on the other side. So insert, this is a very basic one, and here is the bearing. Okay. Another very important topic to mention is about editing or modifying the components from the libraries. So we should not edit a standard component, because otherwise it will not be standard, and that is a basic thing that I think everybody understands. Okay, so let us use this as a rule. There are a couple of other interesting features also in these libraries, which are, for example, the possibility to have a cutting method for some components. And the best example I can give you is, for example, I will start a new 3D. I will make a very, very simple plate, okay, just as an example. Okay, this is a very simple thing, and I will insert now a screw. I will use a big one, M20 for example, and 100 millimeter insert, and even that at this moment you still don't know how to manipulate this, I will put it on a position, and again it will be explained on one of the future lessons. So I will insert this in the middle of the plate. Now I will rotate it. Okay, I will rotate it, and it is here. Perfect. So I will, it should be in this position, but for understanding I will put a little above the plate. So now I will say okay. What happens now, because we are working with solids, is that this screw is intersecting this solid, okay? But the software has a capability regarding the standard parts, that is, there are features inside each type of solid that allow us to cut other parts according to the functionality of the part we are inserting. And in the case of the screw, if I go to a function that it is cut one solid by the other, for example, it is solid used to cut, I can say, the screw, and I want to cut this guy here. And now, because the software understands that this is not a regular solid, this is a special, this is a screw from the library, it asks me if the cut to be done, it is a plain cut where it will look for the screw and it will make a negative copy, or more clever, if it is a modification according to the type of a solid, what they call here the counterpart, and that is what I want. And if you see the result, I will try to zoom in a little, okay, you see that because when we put a screw here, the screw should have a little gap to be assembled properly, to work properly. The software calculates a gap for this without saying, oh, do the counterpart cut, but then had a following function saying you should have had a gap. No, the software knows this immediately and automatically. So basically this is how to work with the libraries. Just to make a little resume, you can insert parts either in 2D or 3D. The libraries are the same, and you should not edit these standard parts, because even in production area, if you change a standard part on a machine, if you have a problem, if you break a part, or if you need to replace that part, then you will be in trouble if it is modified and not as a standard component. So basically these were the commands. It's very easy to work with these topics. Again, this is the first lesson of this new section, and I hope to see you again for the next and last lesson of this section, called the libraries and the mechanical calculations.